Can I start? Okay. Hi everyone, thank you for coming to this session. My name is Nicola. Today we're going to talk about, I have no idea what my app is doing. So first, mandatory slide about me. So I work as Android engineer at Yelp. Yelp is an American company. We are based in San Francisco, although I work for the German office in Hamburg. I love to call myself a community lover. I run a couple of communities in Italy and in Germany, and those are my passions. But today this talk is not endorsed by my company. This is stuff that I love to talk about, so it's not Yelp related. So I have no idea what my app is doing. The title is catchy, and I would love to say that this is not a classical technical session. We can call it like maybe 50% technical and 50% inspirational. I want to raise awareness. I want to tell a little bit about my experience onboarding big code bases and actually understanding what my Android application was doing. And given that I'm from Italy, I think we're gonna use some metaphors to make sure that the concepts are easy to understand. And we're gonna talk about something that me, as Italian, I really enjoy. That is food. So whenever I go around, especially in Germany, I really enjoy to get like pizza and try like what other culture think that pizza actually is. But you know, I always want to know like what's inside my pizza. I want to get to know my pizza. I don't like Hawaii pizza or stuff like that. So I really want to get to know what I'm working on. I really want to get to know my code base. So how do you actually start? So how do you start eating a pizza? How do you start onboarding on code bases that you're not aware of? So if you're lucky, you maybe start a project from scratch. So you set up the foundation, you create everything. But in the majority of the cases, you just onboard on code bases that you're not the first author. So you need first to understand exactly what that app is doing. So how do you start? First, one bite at a time. You can't expect to learn, get the entire code base immediately. It takes time, obviously. Try to start with small changes, especially if you're a junior. Try to identify if there are sections of the code base that you can touch. Try to change them and see how your changes impact the app. And then another source of that is really useful for onboarding is get in touch with tests. Tests, if they're good written, they tend to be a really informative part of the code base, and they can tell you a lot about what the app is supposed to do. One thing that I learned the hard way is you can't eat everything, also with pizzas. So don't expect to read the whole code base. That's probably sounds obvious maybe, but when I was junior and my first job, the first thing that I did is I will spend some days reading everything just because I want to know what's going on, and that took me a lot of time. I was kinda useless. So I would say try to understand your module boundaries. You will end up working on some modules. Try to understand what's the size of that module and how that module interacts with the core of the app. That should be enough to make you in a good position where you can actually start working. And another suggestion for onboarding big code bases is pay attention to tech debt. Specifically, if the code base that you onboard, and here I want to mention that the app that I'm working on is 2 million lines of code. So when you start working with that, don't try to change the code style. It can be really painful, especially if you have something like this, hey, look, this file is still using Rex Java 1. I'm onboarding. Why can't I just convert it to Rex Java 2 in the meanwhile? You might end up with something like this, Git reverting your last 2 hours of work, just because if that file is in Rex Java 1, maybe someone else had that same idea in the past. And another learning that I had when I was onboarding big code bases is never trust appearances. So if you're from Germany, you probably know this brand. And they do frozen pizzas. This is pizza fungi. It looks pretty great on the picture over there. I don't know if you ever tried this one. I think there are not more than 3 mushrooms on top. So never trust what the outside of your code tells you. So, for example, if you end up having a function that is something like this, is available, return false, that's trivial. Maybe there is also a comment on top, always return false. And when I was like onboarding my first project, I said like, oh, you know what? I'm gonna read everything. I'm gonna add Javadoc comments on every function. So it's like documentation. That's also going to be cool. Then it happens that someone else decided that the module started to be available and they never updated the comment. And then you go there, you git blame, and you realize that you are the guy that wrote the comment. So never trust comments. They're a great source of documentation, but always stick to the code because that's real logic. So I assume now you onboarded your project. You are working at a company since like 1 month, 2 months. Now you want to make sure that the code that you work with and the food that you eat is sugar-free. You want to make sure there are no extra stuff added on top. You want to make sure that you're going bug-free. So to detect unintended behavior of your application, there are a lot of points that you can start investigating to see if the app is behaving in a way that you don't really expect. One of these is using a proxy. So if you're not familiar with proxies, proxies are tools that allows you to inspect the network and see what your application is actually doing under the hood. I generally love to use charts. I know it's paid, but the subscription is not that crazy pricey, so that's probably worth the cost. I'm not working for charts anyway. And you can see all the requests that your application is firing. Unfortunately, it's not that really easy to configure. I mean, it requires some configuration on the emulator and on your computer. And it will look like something like this. You will have like all the requests that your application fired, and you can inspect the body and see like how the communication between your app and the backend is happening. If you don't want to pay for chars and you don't want to, like, especially if like a backend engineer needs to use that and don't want to set up chars on their computer, you can use another tool. It's called Chacker. It's open source. It's on GitHub. This is still a proxy, but works on another layer. It's basically an OKHTTP interceptor. And it works on device without any sort of configuration. It's just a library that you plug in. And again, it's useful to catch unintended behavior. So let's say, for example, that you're implementing like a list and you have paging, and you realize that your application is calling the endpoint twice for whatever reason. You have a bug in your Rx Java configuration. That's really useful. And it's also useful to build awareness. So the UI of the library, it's something like this. This is a test app. So let's simulate some HTTP activity. And you will have this like sort of push notification. You can click and see all the network requests that happened. So this allows, like, for example, a product manager or a designer to get sort of an idea of what is going on. Like, hey, when you click on the button, network is being invoked. So I know it's still techy, but product managers and designers, if they're not, like, if they have a little bit of tech background, they might understand that, and I find it useful. So this is like a fork of another library that is called Chuck, that unfortunately is not maintained anymore. So if you use OKHTTP, especially if you use OKHTTP 4, that's compatible. So think about that. It solved a lot of problems for us. Another place where you can look to check exactly what your app is going on or what your final app is going on is the manifest. So not just the manifest that you write, but the merge manifest. So the actual manifest that will end up in your APK. So if you're not aware of this, the manifest on Android follows a two-step merge process. So first, all the manifests from all of your libraries and all of your modules are collected. They're merged, and then all the manifests from all of your source sets are collected as well, and they're merged. Specifically, there is that tab on the bottom of the manifest that is called Merged Manifest that allows you to show what's the difference between the manifest that you actually wrote and the manifest that will end up in your APK. And a lot of times you have libraries that are pulling in permissions or whatsoever, and you have no idea why you have, at the end of the story, you have that extra permission. With the merge manifest, you can have like colors, and for every color, you see which library is pulling in that specific section of the manifest. And then the last thing that I want to mention, it's enforce conventions. So make sure you spend some time setting up your static analysis on your CI system. We could talk about that for, like, we could give a proper talk about this. I'm just mentioning it. My policy here is always break the build. Like, don't trust warnings, like don't use warnings, just break and make sure that people are fixing whatever convention you want to enforce. Also, think about sharing your pre-commit hooks. I know that in Android community, there is not such a thing about like sharing pre-commit hooks across projects, or I mean, everyone has a different approach to do that. I would love to mention precommit.com. It's a tool that allows to have like a configuration file in your repo and explains which pre-commit should be applied. And this is a nice way to share pre-commit across people working on the same project. So now you onboarded your project, and you also know where to find problems from your code base that might have unintended behavior. But what happens when you're not preparing your own food, but you're getting food from someone else? And you need to pay attention to the place where you get your order, or you need to pay attention to your dependencies, like other code that ends up in your application and that is out of your control. So if you're developing Android apps nowadays, you probably know that you can't really do it without external dependencies. I don't know if you know this meme, but when I got out from university, I think I followed one course on Android development, and they told me, yeah, you need to use SQLite, OpenHelper, and all that stuff. That's not the reality. Like, the reality is that you use the stuff that is over here, external libraries. You can't really live without. And just to give you an idea, you're not supposed to read it, but that's the amount of code that you need to make a network call without using any external library, without using only the code that the Android SDK is providing you. And if you start adding like Kotlin and some proper parsing library and HTTP on top, you will see that your code shrinks, and it's just like way more maintainable, and you will end up with like 3 lines to make the same network call. So you can't really live without external dependencies. So given that you anyway need to get your food outside, I think it's really important where do you get them from. Like, not all the restaurants are the same. Specifically, the restaurants in the context of Android development are the Maven repository. So the places where you get your dependencies from. There are several. I'm pretty sure you're familiar with them, but let's refresh them. There is the Google Maven repo, JCenter, Maven Central. You can also specify other Maven repository using the URL, like in this way. I want to mention Jetpack. It's a really famous service that gets GitHub repository, builds them, and hosts them. And also, you can have your own local repository called Maven Local. So the order of this repository is extremely important. And why? We will see that later. So when you go ordering food, I don't know if you like sushi, but I love to choose, okay? I never go to the restaurant and I say like, you know what, give me the best you have. And I mean, maybe you do it, but in terms of dependencies, that's not always great. In terms of dependencies, that means avoid dynamic dependencies. So they will end up making your build less reproducible. And dynamic dependencies are stuff that looks like this. So JP Sushi, the dependency is Uramaki plus. That means like, give me the best Uramaki you have out there. Also, this is a dynamic dependency. It's like 2 plus, 2, 0 plus. And I want to mention one thing about this, because I saw developers that are using it. Here you would think like, okay, yeah, I stick to 2.0, but that's like the patch version. I don't really care about that. Do you really believe that all the Android developers and all the Java developers out there really follow semantic versioning? There are a lot of libraries that in the 2.0.1, they introduce breaking changes. So pay attention to these. And also if you do stuff like this one, that you can do there in Gradle, that's also dynamic dependency. So think about when you do that, because you never know what you're going to end up having. So there is one thing in Gradle that you can use, and it's called version lock. And I know it's not that much used, but I find it really useful. So in your dependencies block, you can still say, hey, you know what, I always want the best hierarchy. In the configurations block, inside the resolution strategy block, you can activate dependency locking. So if you do this, and you call the dependency task with the --write -locks, this will happen. So you will have a Gradle folder with a dependency lock file inside, and this file will contain the resolved version of all of your dependencies, not only the one that you define, but all the transitive dependencies your build is fetching. And for example, here we can see that Uramaki is at version 3.14. All the subsequent builds of Gradle will keep on using those fixed locked versions. You can obviously update them. So if you run again with --update -locks and a pattern, those versions will be checked if there are new versions released, and they will be updated. You can also do like asterisk and update everything. That it's really useful, especially if you want to like have a CI task that every week runs that. There is this file that you can commit and see actually what is going on, and before updating the logs, you can actually run your test and make sure that your build is still working fine. So let's talk about favorite restaurant. I'm really picky, and I know where is the best sushi that I can get in Hamburg. So you can actually restrict dependencies to specific repository. So you can say, for example, the Uramaki, you want it from that repository only. So here comes the thing that I mentioned before. The order of your repository is important, because they get queried top to bottom. And you can specify rules to prevent resolution of specific dependencies inside specific repositories. For example, inside your repositories block, you can say that you have a repository, there is your internal repo, like repo sushi jp maven true, and this will include the group jp sushi. So those dependencies will be fetched only there. And you can say that inside jcenter, for example, you want to exclude group by regex, for example, JP Sushi. So this allows you to make sure that your internal company dependency are not fetched by external repository. And it's also really flexible, because there are a lot of functions that you can use with regex, and you can specify like all of your configuration. What about if you want to make sure that you eat gluten-free? So what I mentioned here is like, maybe the sushi that you're eating is gluten-free, but there might be ingredients inside that are not. So pay attention to transitive dependencies, like dependencies that are pulled in by others. So on Gradle, you can define constraints for your dependencies. And what is also cool, or at least useful, is you can leave a because message. And we will see how. And the last thing that I want to mention is pay extreme attention to version resolution. And there are some tricky scenarios that could happen. So let's say that for your project, you need Kairen Sushi, version 100. You can define constraints, and you can say that if California will ever be needed, you want version 301. And if sashimi will ever be needed, you need version 4200. So the fact that those two are inside the constraints block means that those are not necessarily dependency, but if they will end up being inside your dependency tree, you specify which version you want. You can also leave a because message. For example, California 300 at gluten. I didn't want that. And sashimi 42 is just the best ever. What happens if another dependency in your tree pulls in sashimi 43, that is the highest version? The highest version will win. You can say force equal true to enforce that specific version, because maybe you really want the version 42. You can actually force the version also at the implementation level. Like, I need this dependency and I really want this version. And if you really need fine-grained control over all of your dependencies, you can still specify this: transitive equal false. I think you will probably never need this, but just to tell you what it does, this basically blocks transitive dependency resolution. So you will need to specify all the dependency manually, otherwise your build will never succeed. So a couple of words related to version resolution. So if you have Kaiden Sushi 1.0.0, you can run the dependencies task to see the dependency tree. And Kaiden Sushi imports two dependencies, California and sashimi, and those are the versions. What happens if sashimi pulls in also California 3.0.2? You will see inside the graph that the highest version will win. In this case, the California 3.0.1 will not be used, the 3.0.2 will be used. Why I'm telling you this? Because you might end up in a situation when those two libraries ends up having Guava 27.1. And one needs the Android, and the other needs the JRE version. Do you guys know which version will win? No, the JRE. Because it's Gradle used the compare function from string. So those are string, and the lexicographically highest string will win. So what I wanted to say here is I saw there are libraries that are using text inside the version. Pay attention to that. I think from one of the upcoming version of Gradle there will be support for variants that allows to have this notion of Android and JRE not inside the version but inside the artifact. That will prevent scenarios like this. But just make sure that versions are resolved using string.compare. What about the quality of the food that you get? What about health checks? You want to make sure that the quality of the fish is the best. So unfortunately, the current status of the dependency environment on Java and Android, it's not the best. Dependencies are really hard to verify. So when you publish artifacts on Maven Central or in JCenter, you generally publish also MD5 or SHA hashes of your artifacts, and those are checked if they're there. But the problem is that the GPG signatures are ignored. So I don't know if you ever experienced publishing libraries, but you know that you need to have a GPG key and sign your artifacts, otherwise you will not be able to publish. Those signatures are basically completely ignored. We will see how. So this is our library on Maven Central, and there are those ASC files. They are actually the signature of the artifacts. Basically, I don't know what's the percentage of people that are actually looking at that file, but your build system is ignoring them. There is actually a ticket on the Apache issue tracker, and the problem here is that there is no easy way to relate a developer to a GPG key. So I will need a way to say hey, I am Nicola, that's my library, and that's my GPG public key. You can use it to verify my artifact, so you can be sure that I'm the developer that actually uploaded their artifact. Ideally, the POM file could be extended with those sort of information. Unfortunately, Android developers are not, really interested in these kind of things, but they can be risky. So this ticket is open since a while, and there is not much movement. So I don't expect major solutions coming out over here. But my purpose is to raise awareness and let you know that stuff can go really bad. And they can go really bad, and they can lead to a scenario that is this one. So there were a blog post, I think 1 year ago. It was called a confusing dependency. So here I call it a confusing order. And what's the problem here? The problem is that what you see on GitHub is not necessarily what's inside your build. So what you see on GitHub when you open the source code of a library is not necessarily what your app will actually use. That's extremely important to understand, because you might end up in a kind of an attack that is called XBI, cross-build injection, and you will have code in your build that you don't expect, and might have malicious side effects. So malicious packages got uploaded for Timber and Android audio recorder on JCenter, and Android developers just started using it. The problem is that the real package, for example, for Timber or Android audio recorder, was not on JCenter. So JCenter had a free spot for that artifact. And stuff got uploaded on JCenter, and yeah, developers starting to use it. That's the link to the original blog post that I really invite you to read if you're interested into these kind of things. And the code looked something like this. That's the Android audio recorder library. And in the constructor, the library was just like saving the instance of the activity, and that was trivial. Like this was the code that was available on GitHub. But if you get the dependency from JCenter, if you open the jar, you will see that the code is doing that plus starting a thread. And the thread was doing stuff like trying to resolve, making like a DNS resolution request. And inside the DNS resolution, they were like adding model and device of the device inside the host name. So that data was sent on the network somewhere. You might not even notice this stuff. It will just happen, and you are starting to distribute this to all of your users. And what was the problem? The problem was that Android audio recorded was in Jetpack. That it's a great tool, but there was at the bottom. So your Gradle build, whenever you request Android audio recorder 030, it will start to ask Google, hey, do you have it? They don't have it. We'll go to JCenter. JCenter used to don't have this dependency, so ideally you would have asked Jetpack to get it. But someone else uploaded stuff on JCenter that had that same dependency. So if you comment out Jetpack, the build still succeed. And that's a big problem. There were like postmortem from JFrog and JCenter. God. It's interesting. It's not super much detailed, but I really invite you to take a look. There is like an overview of what actually happened, course of events. And unfortunately, yeah, the description is short, but what is long is the list of all the packages that got uploaded. And the reason how they managed to upload it, it's so stupid. Like, they just used Jake Wharton. There was a free username. So, yeah. That's the scope of my talk. I wanted to raise awareness about this. This kind of attack actually are not new. They are famous also in other environments. Specifically, there is this blog post. I'm harvesting credit card numbers and password from your site. Here is how. This is related to Node, so it's extremely interesting. I invite you to read it. And I think 1 or 2 weeks ago, there were these other blog posts. Want to take over the Java ecosystem? All you need is a man in the middle. So about this one, a couple of other words. So this kind of attack happens if you fetch your dependencies using HTTP rather than HTTPS. This could happen based on how you set up your Gradle. Like if you have a Maven repository and then you write an HTTP URL, you will just use plain HTTP to get dependencies. And if you happen to be in a man-in-the-middle attack, someone else might answer instead of the Maven repo and provide you dependencies. And now you will say like, yeah, okay, come on. How often it will happen that I will be in a man-in-the-middle attack? But if you just like have an access point and you create a network and you call it Starbucks and you go in the center of Alexanderplatz and you sit down there, people will get connected. And especially if you start building Android stuff and you connect to that network without password and you fetch those dependencies, they get cached in your local cache. So you will reuse it also when you go back to your office. So pay attention to this. And the last thing that the last tool that I want to mention is this dependency check. So this tool doesn't really solve the problem that I mentioned, but it's useful to check if some of your dependency contains security flaws or vulnerabilities. So there is, this is from OWASP, and there is this list of all the vulnerabilities known. So this tool will check your Gradle build and will check if you're using one of these dependencies. I will tell you, hey, you're using this old version of this library that contains vulnerabilities, like just update. But this will not prevent you from situation like where you think you might you're using OKHTTP4, but you're actually using a version that is OKHTTP4 with some sugar added on top. That's pretty easy. It's just a Gradle plugin. You enable like that, and you have an extra task. There is dependency check analyze. It will take some time because it has to download the list of all the vulnerabilities and checks your stuff. At least I think the first build is a bit longer. But it's kind of useful to anyway make sure that your app is secure and you have good quality code inside. So, to wrap up, I hope you got some insights and you learned something new to like how to onboard big projects or like get to know your pizza. Make sure like you're able to like find unintended behavior and you go sugar-free. And most important, you watch out where you get your food from and where you get your dependencies from. And with these, I'm done. Thanks.